then send the data with the working line, the protection line, and send the PON if switch event message. After that, then when the OLT receives the PON if switch event, then it will activate the data path for the backup ONU LNID, because we have the protections LNID. Each laser has its own LNID. Deactivate the data path working ONU, and then send the resynchronization for the gate message, and send hold over N, because that particular ONU, that affected ONU, the state of that affected ONU is in the hold over. It cannot send any data during the hold over. After it will receive the hold over, it will register and processing the gate message, which is the synchronization between this ONU and the OLT, and then send the report queue with the DX number 2. So I hope I can explain clear to you. If any questions, again, you can just directly raise your hands. So here's the simulations scenario. We have 32 ONUs and so on. This is the assumption. We have randomly fault occurs in the ODN 1, 2, and 4. So maximum in this simulation, we generate 4 faults happen at the same time in the system. And what happened? We are going to see based on our simulation results. And we compared our fault dynamic bandwidth allocation with the IPAC no fault. It means that this one is the original without any fault, and we compared if what happened is fault. And obviously we can see if something happened to the system, it means that the performance of our system should be better or worse. Should be better or worse? It should be worse. Right? It should be worse. Here is the traffic proportion. So the interarrival is fixed. It's based on the citation 11. It emulates the T1 data for the voice, and it's around 40% of the total upstream bandwidth. And the rest of the remaining bandwidth of the EF traffic will be occupied by the AF, the video, and the best effort traffic, around 40% and 60%. Basically, probably in this slide, I just show you a few of the pictures. If you are interested, then we can discuss more, because in our simulation we run also with different metrics of system performance. So here's the overall EF packet delay. Just to note to you that this delay is not end-to-end delay. It's not between the end-to-end delay. It's between the OLT and ONU. So here we can see that this is the normal one. And what happens if the 1 fault, 2 fault, and 4 fault occurs? Obviously, like I mentioned before, that if something happened to the system, of course, the delay should be increased because you have something wrong with your system. But what we care is that we need just to guarantee the EF packet delay not guarantee the EF packet delay below 5 milliseconds. Because according to the standard, if you have a delay more than 5 milliseconds in the local, for example here, then it means that you have some problems with the voice. Probably you cannot hear and so on. So basically, we can have less than 5 milliseconds, so it can be categorized as accepted. And for the AF, you can see here the 4 faults. You should have a very high, not a high, yes, it's a moderate high delay, because mostly the packet is congested. Because now we have 4 faults happen in the system randomly. It means that the adjacent node have more requirement if we're talking about in terms of the bandwidth requirements. So here's the normal one. You can see it's Normal one, it should be like this. But if something happened, then the EF is quite increasing, because remember, we need to satisfy first the EF traffic. So if we satisfy the EF traffic, the other traffic we try to maintain. And for the AF, I think it should be below 20 milliseconds. And you can see here, probably, if we are watching the video and something happened to the system, then we will have some stutter or some blur picture or something like that. And here is the packet delay drop probability. Basically, this one is the total packet drop. So, based on our simulation, we have another data. Most of the data that has been dropped in here is for the BE traffic. Because what? The BE traffic is the lowest priority packet in the one system. So we have below 8%. Actually, it's quite acceptable because it should be, I think it's 20%. It's around 20%, less than 20%. It's still acceptable in the highly load. So here is the system throughput. Yes, for the system throughput, probably some of you now is asking, you said it's worse, and now you said it's higher. Why is system throughput is higher? Yes, because if we have something happen to the system, then that particular ONU can be categorized as dead ONU. It means that the overheads of that particular ONU will be what? Will be gone. It means that the system throughput can be more higher than the normal one because of the control message overhead. Because now we don't have 4 ONUs overheads, so it will increase the utilizations of the upstream bandwidth. I think so. Yes, here is the summary and extensions. I hope it can give you some ideas. So if you have any questions or suggestions, just directly ask me. Don't hesitate to ask me any questions. Thank you. I think only that I can share with you. Thank you so much.
Any question to Andrew? And I also forget to introduce Ali here. So Ali here. So Ali also from the same name with Andrew, and Ali is from Iran. So if any foreign country student from Iran, check with Ali, please proceed. Is there any question for Andrew and Ali, especially from Indonesia students? I think because from the same country. No. Maybe I ask one question and later you can follow my question as well. So Andrew, we just talk about the adjacent nodes. It is possible you attach to adjacent nodes to increase the availability of the system.
Yes, so the question is, can we increase the availability of the system? Basically, probably I can answer yes. In terms of the link fault and transceiver fault, yes, we can increase the system availability, but we have some problems also about the adjacent node, because this adjacent node need to handle the affected node data. It means that we have many problems or many dropping in this particular ONU. This particular ONU will become the hotspot, and I just showed the results about the overall delay. But if we can see inside only this particular ONU, we can see actually we have quite high delay in here, in this congested ONU. So we can increase the availability, but we have another problem, which is the hotspot of the ONU. It means that, remember that in our proposal, we just use the M bandwidth times the, how many number of ONU affected, then we times the maximum bandwidth. But for the future work, probably we can use some predictions so that we can offer more enhancements in this hotspot scenario. So the major problem is here for the future work. I hope you can answer that question.
Question to Andrew. So maybe you can send an email to Andrew if you have some question, and maybe later you can check together. I think Ghana 6 or 7 in Indonesia best student PhD student here. So if no question here, we show a big hand to Andrew and Ali. Thank you.